Hello everyone. Today we are going to talk about standard SID 1. I can interpret data shown in various data representations, dot plots, histograms, and box plots. If you've already completed assignment number 1, we are now looking at the day 2 of notes. Okay, and we begin with an example of error analysis. Okay, this example is a little easier to look at in your notes because you can see all 4 graphs at once, but we're going to go ahead and start with what we can see on my printout here. Below is a list of the number of students in different classes at a community college. We have this range of students here. Okay, which graph is correct, which graphs are incorrect, and why are they incorrect? So we look at the first graph. Okay. To really do this, I kind of need to make my own histogram, or at least have an idea of what's going on. So just a quick review from yesterday's notes is that you need to arrange these from smallest to biggest. So we have 15, okay, and then the next number would be a 19, okay, and then it looks like we have a 20, a 22, a 24, a 25, a 28, not once, but twice, 29, a 31, 38, sorry, this is a 3, 38, 32 should have been in between here, 42, a 44, and a 52. All right, so this is what we know. Okay, so I'm going to go ahead and just glance at their ranges. One of the things for a range to be correct or incorrect is it needs to have a consistent number that it's counting by. So when you look here, between 15 and 19, that represents 15, 16, 17, 18, 19. There are 5 numbers. Between 20 and 29, there are 10 numbers. Between 30 and 39, there are 10 numbers. And then it goes back down to 5. So already I know that graph 1, no good. Okay, it's not counting by a consistent interval. For this to have been okay, they would have had to go 10 through 19, 20 to 29, 30 to 39, and 40 to 49. And then possibly adding then a 50 to, oh, sorry, this is not 5. This is 15 numbers. A 50 to 59 to make that consistent. All right. When we drew our histograms, we also stated that the bars should be touching. Okay, so we're going to go ahead and look at this one and see how well it's doing. But before I do that, I'm going to make a quick tally chart. Okay, and I'm going to make my ranges kind of follow along with what they look like they're doing. And it looks like a lot of them are starting with 15 to 24. So I'm going to go ahead and do that. So from 15 to 24, then the next jump would be from 25 to 34. After that, it would make sense to go from 35 to 44. After that, from 45 to 54. How many times does this occur? Between 15 and 24, I have 1, 2, 3, 4, 5 numbers. 1, 2, 3, 4, 5. Between 25 and 34, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, sorry, 25 and 34. Let me recount really quick. 1, 2, 3, 4, 5, 6. Okay. Between 35 and 44, I have 3, 1, 2, 3, and then I have 1 falling in the range of 52. Okay, so I'm just going to count these really quick. It look like I have 5, 11, 11 and 4 more makes 15 numbers, and originally I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm good. I've got everything covered. Okay, so now let's check our bars. Between 15 and 24, it says that I have 5. That looks good. Between 25 and 34, it says that I have 6. But between 35 and 44, it says I have 3. And between 45 and 54, it says that I have 1. This one's looking pretty good so far. Okay? Let's look here. Between 15 and 24, I have 5. That's good. Between 25 and 34, I have 6. Between 35 and 44, I have 3. And between 45 and 54, I have 1. Okay? This one is a little bit better of a graph because it's showing that it's continuous and it's not giving the same gaps that it did on graph B. Okay, and then here we have a 5. This one is, okay, this one is incorrect because your graphs should be of equal width, and this right here is a little wider than everything. So although the numbers are correct and correct in their spots, your graphs should be of equal width. Okay, so of our options, graph C appears to be the best. So it says which graph is correct, C. Which graphs are incorrect and why are they incorrect? A was incorrect because of a range. Okay, B was incorrect because the bars weren't touching. And D is incorrect because the second bar is too wide. Okay, that completes our first example. Next, we move into example 2. And it says the number of laps around a track for 5 runners are 9, 13, 15, 3, and 5. Display the data using a correct box and whisker plot. Which graph is correct? Okay, so let's just review our box and whisker plot. We need to arrange the numbers from smallest to biggest, which seems to be a common theme between all these problems. So there are my numbers from smallest to biggest. Remember that a box and whisker plot has 5 values. Okay, you have a lower extreme, which is 3, and my upper extreme is 15. So I'm going to go ahead and look at these and see, right now, can I eliminate anything with that information? So starting at, this one starts at 4 and ends at 14, so that's not fine. This one starts at 4 and ends at 14, no good. This one starts at 3 and ends at 15, and this one starts at 5 and ends at 15. So already we know our answer, but let's just continue on. Okay, let's make sure we've got it. Okay, based on this, we should know a couple other things. We should know the median value, and our median is 9. Okay, this is the middle number. Okay, because we have an odd number, we're going to use this 9, and our lower quartile number is 5. And using the 9, our upper quartile number, so the median of the upper quartile is 13. Okay, so here's what we have. Now let's check it, make sure those 5 values are correct. We have a 3, the next number we have is a 5, then we have a 9, a 13, and a 15. So C is our correct choice. All right, we are now moving on to example 3. It says the high temperatures in Concord, California for October 1st through 15th are given below. Okay, look at the histogram of these data. What is the error in this histogram? Okay, I don't know what the histogram's error is, but I could look at their scales. That's always a first clue. Let's look and see if that's okay. From 70 to 73, we would have 70, 71, 72, 73, 4 values. From 74 to 77, 74, 75, 76, 77, 4 values. Good so far. 78 to 81, 78, 79, 80, 81, 4 values. 82 to 85, 82, 83, 84, 85, 4 values. 86 to 89, 86, 87, 88, 89, 4 values. Okay, our scale is consistent. It's counting by 4s. All the ranges are worth 4. So the next thing I'm going to do is just make a quick frequency table, assuming these are right. From 70 to 73, 74 to 77, 78 to 81, 82 to 85, and 86 to 89. Okay, now I need to count how often these happen. So between 70 and 73, there's 1, 2, 3, 4. 4. Okay, between 74 and 77, I've got 1. 1. Between 78 and 81, I've got 1, 2, 3. 3. Between 82 and 85, I have 1, 2, 3, 4, 5. 5. Between 86 and 89, I only have 2 left. So I'm going to count my bars now. Between 70 and 73, it's saying it's 4 high. Between 74 and 77, it's saying it's 1 high. Between 78 and 81, the height is 3. 82 to 85, we have a 5 here, and it's saying that my graph ends at 6. And then this is 2. So what is the error? Again, we're focused on error analysis today. The error is in the range of 82 to 85, the bar should only go up to 5. Okay, so you need to explain what's wrong with it. All right, moving on now to the next example. Okay, we are now looking at example 4. And this example follows along with the exact same information as before. So I'm going to go ahead and arrange these numbers from smallest to biggest, because that is our first step in a box and whisker plot. Here we go. The very smallest number I have is 70. 70, mark it out, it's been used. After a 70 comes a 72, mark it out, it's been used. After a 72 is a 73, mark it out, it's been used. After a 73 is an additional 73, mark it out, it's been used. After that is a 76, a 78. Okay, after 78, it looks like we have an 80, and then an 81, and a 82, 2 84s, three 84s, okay, an 85, an 86, and an 87. All right, what are my extremes? Let's look at our extremes first. Well, according to this, my lower extreme is 70. My upper extreme is 87. 70, 87, that's not my problem. Okay, what else could be wrong? Let's calculate the median next. The median is the middle number of the data set, so I'm going to work my way in. I'm going to actually underline since I got a little sloppy with this. So here, 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 here. This gets underlined. Then we're on to this. Here, 81. My median is 81. It lands right in the middle. Okay. After this, we're going to go ahead and now figure out my lower quartile number and my upper quartile number. Okay, my lower quartile, since I had an odd number of numbers, I ignore my median now and I'm calculating the lower median. So I go here, 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 73. Okay, then I do the same thing for my top half. Here, 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 84. All right, let's check this graph and see if we can find out what's the mistake. All right, so we begin with the lower quartile is 70. Fine. The the lower extreme is 70. The upper extreme is 87. Those are fine. The lower quartile we have at 73. 73 seems fine. Okay, the upper quartile we have at 84. That seems fine. The median is 81. What, if anything, is wrong with this box and whisker plot? The answer for this one is nothing is wrong. The graph is fine, and we just showed all of our work to verify that this graph is fine. All right, Marissa recorded the heights in inches of 17 students in her homeroom. The data set she gathered was 66, 63, 60, 55, 73, 59, 59, 63, 71, 61, 65, 64, 64, 69, 65, 66, 64. She created a histogram to display the data. Which of the following are possible intervals she could have used in her histogram? Guys, regardless of the type of graph we do, the first step is always to really figure out what are the numbers we're dealing with. Okay, so I'm going to go ahead and start with my lowest number is 55. Mark it out. After a 55, it looks like I have two people that are 59. After 59 is a 60. After 60 is 61. After 61 is 63 twice. Next comes 64 three times. Okay, and then we have a 65 twice. And a 66 twice. And a 69. And a 71. A 73. And that completes this data set. I'm now going to make sure that I have 17 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17, we are good to go. It says, which of the following are possible intervals she could use in her histogram? Okay, so let's look at the numbers. We have 55 to 73. That is our range of numbers. They need to be consistently counting. So, 60 to 64. Could we start at 60? No, because we have some numbers under 60, so that's not going to work. Between 55 and 59, all the way to 74, this will take care of all our numbers. Let's make sure the intervals are consistent. So we would have 55, 56, 57, 58, 59, 5 values. 60, 61, 62, 63, 64, 65, 66. 7 values. Already, I can say that this is wrong because it's not consistent intervals. 55 to 59. We already stated that was 5 values. Let's look at 60 to 64. This is also 5 values. 65 to 69, 5 values. 70 to 74. This is looking good. And then could we start with 60? We've already said that we can't start with 60. 60 is no good. So which of the following could be used? The answer choice here is C. Example 6. Sarah used box and whisker plots to show the points she scored in her basketball games this season. She used different plots for the home and away game data and produced the graph below. Unfortunately, Sarah cannot remember which plot represents the home game and which represents the away game. Which fact can she use to determine which set of data was used to create each box and whisker plot? Sarah scored at least 5 points in every home game. Okay. That's not that helpful because in our games, regardless of which one we're looking at, we have 5 points because a box and whisker starts with 5 data points. So nope, not liking that. The mode of the set of data of the game scored was 14. We never at any point discuss mode in a box and whisker plots. Instead, we do median several times. Sarah scored 23 points in an away game last week. Okay, 23 points. When I'm looking at that, I can see that this has 23. Nope, doesn't have 23 points. This one's ending at 21. This one's ending at 25. That 23, that's not showing up anywhere right now. Sarah played more home games than away games. That doesn't help us. We're going to go back to this one. Sarah scored 23 points in an away game last week. Well, if this one only goes up to 21 and this one goes up to 25, then we can now say that this is the away values because 23 could be a point on this line, and this has to be our home games. Okay, so C is the thing that helps us out the most. Going on. Example 7. The low temperatures for Nashville, Tennessee for October 1st through 15 are given below. Use the data to make a box and whisker plot. All right, so we are arranging these numbers from smallest to biggest again. Okay, we begin with a 52. That appears to be our smallest. Next is another 52. Mark it out. After that, we've got a 54. Another 54. Okay, then we go on to our 55s. Another 55. After 55, it looks like we have two data sets that are 56, here and here. After that, we have a, oh, I didn't even find my 49, thank goodness. It's at the very back. All right, after 56, we go on to a 58. Looks like a 60, a 63, a 64, 66, and 67. Okay, these are my data sets. Now let's make a box and whisker plot. We need to find 5 exact data values, starting with our lower extreme being at 49. Find 49, make a dot. The upper extreme is at 67. Find 67, make a dot. Okay, then we need to find our middle number, our median. Okay, in the middle, we're going here, here, here. This one, this one, this one, this one. Oh, 56 is my middle number. Coming to 56 and making a dot. Okay. After this, we are going to now find our lower quartile. Okay, our lower quartile, since we had an even or an odd number of values, we're going to just go like this now, ignoring the 56. So here, 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 54. 54. And then we need to do the same thing on the top. Here, sorry, here, 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 63. So my upper quartile is 63. 63 is here. Okay, our last step is we need to make a box from quartile to quartile, and then we need to make a line through the median. Okay, so there's our box and whiskers plot. The ages of the board of directors of an insurance company are given below. Use the data to make a histogram. All right, so in a histogram, we begin with a frequency table. We're going to make some tally marks or just count them up, but it looks like we have 52 possibly being our smallest. And so I'm going to go from 50 to 54, and then 55 to 59, 60 to 64, and 65 to 69, which should encompass everything. All right, here we go. 52 to 54, I have 1, 2, 2. 55 to 59, I have 1, 2, 3, 3. I just noticed also that there's another 50 right here, so I'm going to come back up and there's 3. All right, now I'm going to go from 60 to 64. I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 67 and 69 is just 2. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers to start. Now I have 3, 6. 6 plus 5 is 11, plus 2 is 13. So we're good. Good to go. Okay, we're going to make our histogram now. 50 to 54. 55 to 59. 60 to 64. 65 to 69. Over here, just count by ones. Okay, remember that your bars need to be touching and that they should be a fairly equal width. I'm not going to pull out a ruler and measure the widths, but they need to look very similar. All right, between 50 and 54, I'm going 3 bars high. Okay, between 55 and 59, I am also going 3 bars high. Between 60 and 64, I now need to make the jump to 5 bars high. And between 65 and 69, it's only 2 bars high. Okay, this is an example of our histogram. George created the box and whisker plot below to display the number of points he scored during each basketball season. Can you find the number of scores used to create the box and whisker plot? Why or why not? Okay, the answer is no. We cannot find the number of scores used to create the box and whisker plot. Why? Because exact values are not retained. That means we lost the exact values. All a box and whisker plot does is it shows us these 5 numbers. Okay, our lower extreme, lower quartile, median, upper quartile, and upper extreme. 5 values. This could be made off of 20 different games, but we only know 5 values. Exact data values have been lost. Okay, looking at the same thing, can you find the range? The answer is yes. Okay, so yes, we can find the range. All we need to do is take 14, which is our upper extreme, and subtract 4. Our range is 10. Okay, so this is very possible. Same graph. Can we find the mode? The mode by definition is the most frequently occurring number, so the answer is no. We cannot find the mode because exact values are not retained. The counseling department at Glendale Community College created the following histogram to display their class sizes. Explain how to determine or why you cannot determine the number of classes used to create the histogram. Okay, here's what we have. We have how many students are enrolled in a class, and we have the frequency of those classes occurring with that number of students. Can you determine the number of classes they use to create the histogram? Yes, absolutely. We have 2 classes here, 7 classes here, 3 classes here, 3 classes here. Add them. 2 plus 7 is 9, plus 3 is 12, plus 3 is 15. So all we did was we added the frequencies. "15 classes were used." Okay, same question. Okay, the counseling department at Glendale Community College created the following histogram to display their class sizes. Explain how to determine or why you cannot determine the range of the class sizes that they used to create the histogram. Okay, can we find the range? No. Why? Because exact values are lost. Okay, so here's what we have. This goes up to 54, but the highest number could have been anything in that range, not necessarily the end number 54. It could have been a 49, it could have been something else. All right, moving on. Still the counseling department at Glendale Community College, they want to know if they can find their median. Can we find the median? No, because the exact values are lost, but it says, if so, what is the median? But if you cannot find the median, what interval do you think it must lie? So I'm kind of thinking the middle would probably happen here. So the median probably occurs between 20 to 29 students. Okay, counseling department, one last time at Glendale Community College. Can we determine the number of students used to create this histogram? The answer is no. Why? Exact data values are lost. Okay, they have lumped them together. 15 to 19, 20 to 29, 30 to 39. This could have a class of 35, 36, and 37. It happened 3 times in this range. We have no idea how many times each one occurred. All right, at this time, we are done with day 2 notes. You now need to go on to the day 2 assignment and come back and make sure you get day 3 done soon. Thank you and have a good day.